Hello, and welcome to a LØRN conversation. My name is Silvija, and my guest today is Zouganeli, who is a professor on assistive technology and intelligent systems at OsloMet. Welcome, Evi.
Hello, welcome. It's very lovely to be here.
Evi, did I pronounce your surname correctly?
Yes, I was astonished actually, because you didn't ask me before you recorded, so it was really good. Thank you.
But here I am, actually uncertain whether you're Italian or Greek or something else.
I am Greek, and my name is probably Italian, and I'm sure we are all a bit of a mixture of bit of here and bit of there, but I'm Greek.
Greek, very cool. So I'm just going to say a few words about the series, and then I'm going to get on with our conversation. LØRN is doing a series of about 10 new conversations about applied AI. And what we want to do is show people, we've shown quite a lot of entrepreneurs working with AI. We have also shown a few public sector workers on AI, but we want to go broader and basically cover many interesting perspectives of people who use AI in practice today. And it is especially your work related to human and AI interaction for people with dementia and assistive technologies that I think is super exciting here. So it's a general conversation where I'm trying to learn about what's moving and what's shaking in assistive AI. Okay?
Sure.
Excellent. I always start by asking people to present themselves in a personal way, because we have this pedagogical model and theory that people learn from listening to a conversation if they feel like they are included in it and they know you a little bit. So who's this person, Evi, and why does she care about AI?
Oops. Yes, I've been working at OsloMet since 2011 with AI, yes, intelligent systems. So I'm at the Department of Electrical Engineering, and we have a focus on automation and also in medical technology. So I had an interest in applications that have to do with, come closer to people, that are really useful for people, that have to do with maybe with health applications. And that's how I got involved in assistive technology together in collaboration with people from the health department. And then we started with this project that was assistive technology for people with cognitive impairments or dementia, and had a field trial at Skøyen Omsorg. And this is just one application of intelligent technology. It's just a start in a way, and it's kind of the same principles can be applied on other things. So yes, that was like where I am now. I don't know if that's it wasn't very personal. I don't know if
tell us personally. Where do you come from in Greece, and what made you want to study electrical engineering, or what you studied?
Yeah,
applied physics. Sorry.
Yes, well, yeah, both. Yes, I come from Piraeus. It's the port of Athens, but really my parents come from a small island in the middle of the Aegean Sea. Maybe that's why I came to Norway. There's a lot of sea here as well. So yes, I studied applied physics with electronics. And then I did a master's and PhD in the UK at UCL, University College London, in electrical engineering. And the focus of my PhD was more like on nano devices. And then I did a postdoc in Zurich, also in kind of the same stuff. And then I came to Norway and worked at Telenor for 16 years, Telenor Research and Development. And there I worked with broadband networks, intelligent networks, network management, optical switches. So it kind of changed the focus. And then I worked 1 year at Radium Hospital, or 7 months between jobs. And then this job at OsloMet came, and I started there in 2011. So it's been a journey to come like from, how shall I say it, to kind of scripted intelligence in system to artificial intelligence, which I think is kind of a natural journey. It was natural for me.
So you have a lot of difficult words here. You talk about intelligent systems. You talk about perception, anticipation. You talk about human AI interaction and support systems. So I need to ask you to translate this into pictures and talk to people who don't know what an intelligent system is in engineering or computer science. So if we just paint a picture around one of the projects that you're working on now, I think it's easier for people to understand the concrete. Or the projects that you worked with. This Norwegian Research Council funded project on technology, health, ethics, on assistive tech for elderly with cognitive impairments. What was the project about?
I think the project has so many, how shall I say, parts, because it was interdisciplinary. It was very, very interesting. But if I go in the details of that, we will probably not have time to say anything else. So I think I will say more like what does it mean intelligent system in this context? So for example, in this case, kind of an intelligent system could have been like a smart home. And there are commercial smart homes, like you can buy equipment to have a kind of a smart home. So when we speak about intelligent systems generally, we are speaking about, a system that can somehow do something automatically. And then the question is that intelligent? I mean, that's not particularly intelligent. It's kind of doing one function that it has been programmed to do. So depending on how you define it, you could say that this is not an intelligent system. It's a very dumb intelligent system. And it could progress to become a really intelligent system, which means a system that has, how shall I say, that has abilities and can understand what's going on and can assist you with what you need at the context of what is happening at the moment. And it can learn from what you're doing and repeat it or adjust to your preferences and things like that. I mean, it can be from the simplest thing, like switch on the lights when you enter the room and not start flickering on and off like it is in where I have now my washing machine. When I go in the, this small, I'll call it lager.
Yeah.
Yes. So when I go in this to switch on the washing machine, the light comes on, and when I'm actually trying to put the soap and stuff, the lights come off. So I have to do this to the light and stuff like that. That's not an intelligent system. But so we are talking, today's intelligent systems are automations that are exceptionally stupid. So we want to make them intelligent so that they can actually assist us instead of giving us headaches all the time.
So I want to play ball with that image. So I have a Google Home, and I'm surprised actually at how often it just turns itself on without us intending to do so and starts talking back, and how difficult it is for it to learn. Especially knowing how extremely able Google is with AI. So I guess there is still a big disconnect between some of the most advanced applications and what we put into these intelligent systems we call smart homes. And what you're trying to do is understand, if I go back to this project, a specific use of an intelligent system, like let's say a smart home, or maybe even just a room that could be maybe a sort of a very medically enabled room for a particular group of people. It could be elderly with dementia, or it could be people with physical impairments, or it could be, young children left home alone. So it's part of the system that you're trying to make more intelligent is help it to learn, help it to understand the context, and help it to understand the particular needs of its application.
Yes,
Does that sound right?
So one thing, yes, absolutely. One thing I wanted to say is that you can think of systems that are only software, like this Google thing, or I mean the one you mentioned, and you can have systems that are both software and hardware. And when I talk about intelligent systems, I'm talking about systems that have a body. So this body can be, so not just software on your PC, if you see what I mean, that has some intelligence. But for example, a car that is intelligent, you would have, all this talk about self-driving cars. They would have to be much more intelligent than they are now to be possible to use actually in real systems and be reliable and safe and all that stuff. I mean, it's some way to go before you have that. And it is also the interaction between the software, the hardware, and the people involved, and the environment around, and the people involved. And it's all this that needs to work. And then the machine will have to understand and behave and, and do the actions that need to be done and take the right decisions and all this. So what I work with in that project that you mentioned, it was in an intelligent system, and it was to begin with this group of people with cognitive impairment that turned out to not have so much cognitive impairment. So they were actually co-producing, we said, or they were collaborating when we designed the system. But that was like one case. What I am more generally interested in is intelligent systems for other applications as well. So for intelligent, for the intelligent car, or for intelligent infrastructure like city infrastructure like traffic lights and this kind of thing, and for industrial applications, because also in the industry you don't have robots that work alone and produce something any longer. The new paradigm is that you have people and robots need to be collaborating, and in order to be able to do that reliably and safely, you need a much more intelligent system. Be it a robot, be it a total system, be it a smart home, be it whatever it is. So it's more
really
general.
This hybrid solution where, it's not either AI or people, it's the human plus AI collaboration.
Yes, I cannot, how shall I say, I cannot affect the people. I'm working with the AI. But then the how shall I say, the purpose is to create AI, artificial systems, intelligent artificial systems that can collaborate with people, can interact safely and meaningfully. So they have to be able to do a job that is more than a repetitive task. Where we are now, as a lot of the AI we have used, it's impressive. I mean, I won't say anything else. It's really impressive what has been achieved, but it is mostly getting loads of data, like medical data, and then doing statistics on it and getting some sort of correlations out of it that tells us something about whatever. But that is, that's not the kind of AI that I am interested in. I'm interested in developing intelligent systems that can do things more like also physical things, if you like. kind of,
So basically, intelligent
something on.
systems. Sorry?
Like switching something on, or lifting something, or moving something, or so you have some sort of automation in the picture. So meaning that you have some sort of physical system that is being controlled, and a body like a robot, a car,
a house.
A house.
Yeah.
Not the house. Well, at least the inside of the house, maybe.
Inside of the house. So automatable systems that not just perform actions, but also interact. Because I heard you also say that interaction is a very important part of this.
Yes, absolutely. And that is both the the kind of communication kind of interaction, like you say something, it replies or whatever, understands the command or gives back information, but it's also the physical interaction. So if you have a robot or some other kind of robot, it can be just any small machine in your vicinity. It cannot start being moving around, and while you're moving your arms around. It could be, it will need to understand and perceive its environment, understand what's going on, and move in a way that so that it doesn't damage you or anything else. And so it's also the physical interaction.
So, Evi, if we go back to thinking in pictures, so what was if you can just describe a few functions or a few desired end states of this smart system for dementia patients. And then I would love you to talk a little bit about your 2 pre-projects as well. You have one on personalized remote physiological mentoring and monitoring. And I think this is going to be a very important part of how we exercise our health in the future.
Yes.
So if you could tell us a little bit about what does it mean? What sort of gadgets does this combine?
Do you want me to say something about the first project, or
the first project first? Yeah.
Yes. So just to say that things take time. So in that project, what we wanted to build was an intelligent system using commercial smart home equipment, so sensors basically, we wanted it to become to be able to adapt to the individual user and assist the individual inhabitant in the way that he or she needed. Well, we didn't get that far. We did like the first step. And the first step is perception and anticipation. So we used, perception is, because you need perception to understand what's going on. And anticipation, it means that that the system can predict what will be the next thing that will happen. And this is required in order to be able to interact with you because, for example, it knows that now you will move from the kitchen to the living room, and then it can be aware of that and not be in the way, for example, or something like that. So you need perception and anticipation, and like the first things you need for any sort of interaction. And so we did primarily these, and we used 2 types of sensors. There's sensors like on-off type of stuff, like you open a cupboard, it's on, you close the the other way around. It's closed, you close the cupboard, it's on, you open the cupboard, it's off, and similar. But we also used a system that is a low-resolution video camera. And that is a commercial system, really, that is a fall detector. But we use this system to use it for computer vision so that we could then identify what kind of activity the person was doing, with a purpose to assist them. But we didn't manage to do the last part. We need a second project for that. Yes. So, but we learned a lot.
I'm just thinking, all of this stuff sounds very available in theory. And then once you start applying it to concrete cases and you want some flexibility, things turn out to be very demanding, as you say. And but I'm thinking even just having solutions like, in Norway, we say komfyrvakt. So it's basically the thing that makes sure that your stove turns itself off properly.
Yes.
As much as they've tried to build in intelligence in these systems, mine peeps all the time and the alarm gets turned off. So, and solutions like this would be super useful to dement people, or, detection of people leaving the house or falling in their bathroom or bedroom.
I don't think it's only for people with dementia. I mean, I would like to have that working as well because, but it's kind of, I think there's so many useful things we could have if they were working properly, because at the moment they can be experienced as more of a nuisance than help. And that's also what, so my colleagues from the health department, they interviewed the elderly people and their helpers and caregivers, etc. And it turns out what they have problems with is very simple. I mean, very simple things like, that this stove thing turns off when you don't want it to turn off. You just leave the room and then half an hour has passed and it switches off the cooking, and you're cooking something that lasts more than half an hour. And then you come back and it's like, oh no, it's not done. Or if it is a person with a cognitive impairment, could even get very worried. What happened now? Why is it not done? I mean, it can get very confused. So simple things like that. But this was, as I said, this is kind of a first step. So what I am interested in is, like you mentioned, this pre-project in human artificial intelligence interaction and collaboration. And we applied for funding from the Norwegian Research Council on this project. We got very much good feedback, but didn't get the money. So we're going to do it, apply again and again and again until we get it. It's we can't be talking about artificial intelligence if it is something that can be only existing in a box, away from us, if it's not safe and reliable to be close to us, communicate with us, to collaborate with us, to do things on our terms, rather than us trying to adapt to it. That's it really has to happen. We really need to move to that level before these systems can actually be useful and safe in our environment. I mean, in our closed environment.
And so the main kind of thread in your research going forward is about really making this interaction happen in
it's not about
ways.
Yes. No, it's not about making the interaction. There are other people that work with that. I don't work with the interaction. I work with the intelligence of the system that will enable it to interact.
Understand.
So it's like how shall I say? It's a backstage intelligence. It's not, so the interaction is not, I don't work with the interaction. Other people work with the interaction. I mean, designing the interaction or all this interface kind of research. I don't work with interfaces. I work with backstage intelligence.
So for
but
people,
you need all the bits.
yeah. So for people who are listening to this and trying to understand a little bit more about artificial intelligence, if they are working in healthcare, they can think of this as something to be coming in the infrastructure that they will be working with, both in hospitals and at homes. People who work in production and industry can think about their automated production lines as something that will become more intelligent in terms of this interaction going forward.
Yes, absolutely. So, for example, in the industry, imagine now, if you, first of all, you don't have so much things being like next to a human and like doing things at the same time together with a human. It's more like the robotics and the production lines, they kind of do things by themselves, and then the people may be in the vicinity, but they do other things next to them. So being able to, if you had some assistant that is robotic and it also does stuff together with you, which is not repetitive. So far we're using systems, intelligent systems that are to do repetitive tasks and heavy tasks. But if that's not what or the next step would be that you have systems that actually can work together with you, like your body. You do things together. Then you need a lot of flexibility, and you need a lot of adaptability and understanding to be able to do that. And also, when it comes to training, nowadays, if you want some machine to do something else than what it has been doing so far, then you have to reprogram it. While we need to find ways where you can show the machine, you can demonstrate, and then it has the intelligence to learn the same way a human or a human child maybe would learn, by observing. And this is also a new paradigm. There are many aspects in it.
What's your estimate on the time frame for this? I'm just thinking most of us don't know enough about, on one hand, I see that there is a huge development in sensors and in, availability of relatively cheap sensors, computing, and programming libraries, perhaps, to keep this together. On the other hand, maybe we are learning that these things are incredibly complex. So,
yes,
where do you think it's going?
I don't know. I have, to be honest, the 2 times I think that I tried to predict how long it's going to take for something to be available, I failed. By a couple of decades. So I will not risk another complete wrong prediction. I don't think it's very easy to predict exactly. I think also it's going to be in steps. It's not like, oh yeah, now we have nothing and then in 2 years suddenly everything is working. It's going to be like small steps. And it depends also who is being involved, because you see that at the moment, there are a lot of big companies being involved, and there's a lot of money in this. There's a huge economic potential, and so the moment big players put a lot of money in something, it's going to go faster, and so I think it's very, very difficult to predict. We need small breakthroughs, several small breakthroughs. And as I said, I think it's going to happen like, oh yeah, suddenly, like, for example, the first time I saw these, how you call those electrical sparkcycle that are like parked everywhere on the pavement. The first time I saw it, I thought, oh, did they manage to build this? I thought we were still like struggling with the algorithms for this balance thing. So I have been surprised both ways. Sometimes I think, oh, wow, this happened like in 5 years. I thought it would happen in 20. And other times I think, oh yeah, no, in a couple of years we're going to have this. And it's like 20 years later, we still don't have it. So we'll have to see. But it's very, very exciting. And I think a lot will be gradually happening. So a lot. No, we're not going to get there like in a minute to the
moon.
Perfect system. I mean, it's not going to happen like that.
So, but I think it's really interesting also to see how progress goes in these jumps and sprouts in a way, but also how we often end up with completely different things than what we thought that we were going to build. How, how adaptive the whole process of innovation is as well. And how we sometimes completely underestimate the effect of something. Like, whether it's elsparkesykler, I think the really interesting thing there will be once this starts working for other kinds of shared transportation tools that are, working for old people or for kids. But I want to ask you towards the end, Evi, about two things. One is, where do you see the biggest potential in Norway? And you talked to me a little bit about the public sector. So I want to, to ask you about what do you see, a bit like me, outsider looking in with much love.
I'm not an outsider still, I don't know. I've lived in Norway for a very long time, but I guess, yes, we are also outsiders to a certain extent because, I've lived also in other places. You could say that. So I think, Norway is a very small country in terms of number of people. And that is both a disadvantage, I guess, but also an advantage because then the threshold to, everybody kind of knows everybody, and the threshold to getting in touch with people is lower than other big places. And if you don't know someone, then someone knows someone that you can talk to, even in the most difficult places. So that can be an advantage. Also, another important advantage is that Norway has a strong and well-educated public sector that also has a tradition in serving the community, and strong industry, especially in some areas, very strong industry. So this makes it can be very promising when it comes to AI. Although Norway is a relatively small country in terms of number of people. But another thing I want to say when it comes to advantage, I think it's important. I think that Norway and the rest of Europe have an important role to play in the development of AI. Because, I'm not worried that AI will want to harm us, but AI can be misused if it falls in the wrong hands. And that's why I think that Norway, that's a peace-loving country, and other peace-loving countries should be at the forefront of the development to make sure, or to do our best so that AI will not be misused. It is a difficult task, but we need to be at the forefront to be able to do, to have the most sustainable kind of attitude or strategy regarding
I think that's
AI.
a super important point, because I think unless we actually compete efficiently, suppliers from China on infrastructure side, or the Silicon Valley suppliers on especially software side, I think will be the ones who define how our AI-enabled future and our AI-enabled houses and everything else will develop. So we have to innovate in order to stay relevant, I guess.
Yes, that too, and also to be a part of the community and be strong partners in this community, not just like, oh yeah, that's lovely. Let us use this and let us use that. We need to be at the forefront, and we need to anticipate the dangers and have solutions for the dangers before they emerge. If you see what I mean. So
very good.
yeah.
So if we are to conclude, Evi, what do you think is the most important thing for generalists, for people who don't know much about AI, from our conversation? What would, if there is one thing you have to, say that you would like them to remember, what is it?
Oops. Well, I guess, for example, we could say, this slogan or whatever, this line coined by IBM, technology, people literate technology rather than technology literate people. So we want to make the technology intelligent so that it adjusts to us and collaborates with us on our terms rather than trying to educate people on using technology, if you see what I mean.
That's a lovely picture. I didn't hear that quote, but it's technology has to be adjusted to us rather than the other way around, and it's really up to technologists to define that kind of solutions, not complain that the users are not picking things up well enough or quickly enough.
Yes, I guess, but of course the technologists, together with the designers, together with the psychologists, the health experts, it needs to be an interdisciplinary effort to get there.
Agreed. Evi Zouganeli, thank you so much for joining us here in LØRN for this interesting conversation about intelligent systems and applied AI.
Thank you for having me here.